Hello, everyone. I hope you are having a great conference and you are learning a lot new stuff. So let's do a thumbs up or down about the conference. Thumbs up or down. We have the master conference here, so ceremony. So it's a good moment to have that feedback. So thank you for attending my session today. And my session today is going to be around different service mesh implementations and how can we interoperate those service meshes. This is a business case that is relevant, especially when the service meshes need to reach some scale, or a big scale, let's say, or it's a different way of scaling a service mesh. As we will go through the presentation today, we're going to show two ways of scaling service mesh, and this is one of them. So this is one of the scenarios that we can think about when service mesh interoperation is needed is when there is a large company which has a distributed team which is working in different places in the world, delivering different services which need to interact with the other services in other places in the world created by other teams, and they don't speak between them. Right? This is not unusual, and these different teams many times need to deal with different regulations. They need to use different pieces of infrastructure in many cases because of those regulations, but also they have different cultures. So they might be coming from a different background, they might be using different products. So their journey to automation, their journey to microservices might have been completely different from one team to another. And that means that the decision towards which service mesh to use or the maturity of that decision might be different as well. So this is the agenda for today, and this is more or less how I'm going to run the talk. So first of all, because there's so many people here, and the background, your background might be completely different, or the skill set that you have might be completely different. So I'm going to try to settle everyone more or less on the same page. I'm going to run very quickly describing the problems that we all have faced as developers, and that why we have moved into a microservices architecture. How real is that? Because we like it or not, we are still living, and we are going to be living for many years in a hybrid infrastructure where monoliths are going to be moving into a microservices, and that process means decomposing the monolith and creating more and more microservices over time, and no one knows really how long that time is going to be. And then I'm going to describe why a service mesh makes sense. I'm going to describe Consul's service mesh product, Consul Connect, VMware service mesh product, VMware service mesh. And then I'm going to describe the work that we have been doing, VMware, Consul, and a couple of other companies around interoperating service meshes, which is going to be released into the open source for all of you to have a look at it and give us feedback and contribute ideally in the next few weeks. I have a live demo, but I think that if things work properly, I'm going to be switching between slides and product. Okay, so we can do this in a, let's say, a better way to illustrate the different concepts and all we are going to be talking about. So I have here a command line, I have here different products, and let's hope everything works. So monoliths, look at the picture. What we have in the picture is really 3 different monoliths, each of them composed of different parts, the colors inside each of the monoliths. And when the monoliths, which are applications, need to talk to each other, need to share information, can be database, can be front-end, a back-end, they need to use network connectivity. These are the lines that we have between the monoliths, right? And the problem with monoliths is well known by all of us. They are complex, they are big, they prevent innovation because we are committing to a technology stack for a very long time. It's a problem with availability as well. So if a part of the monolith is non-functioning, it's difficult to know why the monolith is failing, and it is very likely that the monolith fails completely. So and that's the reason why we decided to move into microservices to revert that situation. So we have the opposite set of benefits to the problems we have mentioned before. So we have agility because we now focus on small pieces of software instead of big pieces. We are not committing to a technology stack forever. We can change the technology stack as we create new microservices. Those microservices are going to be communicating through APIs. It is much more elastic because we can, instead of scaling the monolith, which normally is we scale a monolith using this monolith scales vertically, which means more hardware or a bigger virtual machine. But microservices scale horizontally and independently from one from another, right? So we replicate the microservices, and that's also creates a new problem, that is a stateful applications versus stateless applications. So if we look carefully at this picture and we try to think about this at a scale, what we are going to find is this, right? So we're going to have different pieces of infrastructure in different places of the world. We're going to have different applications with different level of maturity. We're going to have a hybrid monolith, which is being converted into a microservice infrastructure, different degrees of that conversion, different places in the world, across different teams, using different technology stack, but they share the same thing. What they share is, do you see how many lines do we have now? That means that what we have created, we have solved some problems, but we have created new old problems. That is, we have a lot more connectivity now. A problem in any of those connectivity means that we have a problem in the final application, not in the service itself, but we need to think about this as an application is a composition of services. If one of the services doesn't work, maybe the application doesn't work. Or maybe it is resilient, it still works. But think about Amazon, if the shopping cart doesn't work, it is very likely that I cannot finish shopping. And that means that there is no business for Amazon, and that is a problem in the application itself, although not all the parts of the applications have failed. So we also need to pay attention to securing those links. So it's not only about we need to pay more attention to network connectivity, but it is also about how do we secure all those links, how do we monitor all those microservices. There are going to be many teams doing this. So how do we ensure that we have a consistent way of monitoring all those microservices? So this is really, it's a different kind of problem that we didn't have before, or we didn't have before at this scale, because we were monitoring few things which were very big, and now we have reverted the problem. So the way we've solved this traditionally is because developers are early adopters. We've developed libraries, right? So the first problem we found was how do I observe and troubleshoot my services, because I am not yet at the scale. So this is my first problem. And we created different libraries which also have a problem, right? So these libraries were programming language dependent. Of course, there are tweaks we can do. So for example, in the case of Eureka, we can run a sidecar service if my application is not based in Java. But we are complicating things that in the networking world were already solved. Next thing is I am scaling my infrastructure, so I'm going to need to deal with connectivity and control. So I need new libraries to deal with classic networking problems. So I need to create, I need to deal with load balancers. I need to find a way to make my application fault tolerant. So I have different options here. I can use a product that is in the market. I interact with a product through an API, or I use a software-based product which replicates the traditional hardware product functionality. And then as we wanted to move applications into production, then we found security and compliance telling us you are not going to do it unless you prove you can deal with the compliance regulations and you can do all this big list of things in your applications. Security and compliance people and operations people have completely lost visibility of what is going on, because everything is packed, let's say, in the application. So we have now the application, this is the microservices, but we have a lot of new microservices, which is not application logic. It is networking logic, it is security logic that we need to have to make that dream of different microservices connected together a reality. And many times that's a nightmare because of compatibility problems, because of a software that is repeated in different microservices. So as this model scales, then we are having a really, really big problem that has been the seed for the service mesh. So we have tried to do client libraries, and we have failed with client libraries. So the intention of a service mesh, or the rationale behind a service mesh, is how do we revert that situation of having an increasingly complex piece of microservice because of those client libraries that is increasing in number and complexity, and we move back, giving operations and security team the control, the visibility, and the security they were used to have for production environments. So the rationale behind the service mesh is really, let's move out of the microservice, all that logic, to a different place. That place cannot be the networking stack again, because we have already been there, right? So that place seems to be ideally a transparent layer that sits between the application and the infrastructure. And that is the concept of a sidecar. So basically, the sidecar extracts all that information and makes that transparent to the developer. However, to manage the sidecar, we need a control plane in the service mesh, which is able to tell the sidecar what to do, right? So service meshes have two things. One thing is the data plane, which is the sidecar, which actually does something. And then we have the control plane, which is the brain, which is the piece of the service mesh that we are going to interact with. So we are not going to see the sidecar. And this is the model of all service meshes. So the use cases, as you can imagine, of the service mesh are the traditional ones. So we're going to be solving the same problems that the client libraries were solving. So we're going to be discovering, so service meshes are going to provide this service discovery mechanisms, ways to observe in a consistent way big networks of microservices, ideally across a variety of infrastructure. There's going to be control, not only for operations, but also for developers, so they can really instruct the service mesh to the desired behavior of the connectivity of those services. For example, to simulate traffic, test faults in the application. And it's going to provide a layer of security that is really the main driver for production deployments of service meshes. So how can I make sure that developers do not have the responsibility of securing the service-to-service communication? How can I make sure that I am, as a security team, because I am accountable of doing that, I can really enforce. And I can really enforce in a way that is transparent for the developers. And then Consul Connect is an implementation of a service mesh. It is a HashiCorp service mesh. And Consul Connect has a client-server architecture, which is the one that is providing many of the benefits regarding scalability and dealing with the different heterogeneity of infrastructure. And in this architecture, what we have are one server or more than one server to have some kind of resiliency and high availability. And then the servers, which is the server and the clients are the control plane. The servers are going to talk to the clients in each of the infrastructure components that we are going to have. There are going to be different clients. And then the clients are going to program the proxies, which is the data plane. So Consul is providing out of the box an integration with Envoy as a proxy, but their model is pluggable. So we can potentially use different proxies in different implementations of the Consul, different deployments of Consul, or we can use a different proxy in all of them. So having that kind of architecture is what gives them or give their customer the ability, let's say, to have different data centers with different service meshes, let's say, using the same implementation in this case. So these data centers can be physical, can be virtual, can even be virtual machines, not necessarily a cloud-based data center. And there is an auto-join functionality. So as soon as we have one cluster of Consul servers, as soon as we have another one, we can make that new cluster join the existing infrastructure. So scaling is heavily simplified. The service catalog is synchronized across different infrastructure, and the Consul is providing today a bidirectional synchronization of the service catalog between Consul servers and Kubernetes. Consul also provides, very recently, since 1.6, I believe, mesh gateway, which is a way or a need, really, to provide that model of connecting different data centers. So we can, when we are connecting different data centers, we cannot make assumptions of anything regarding the networking space, and we need to secure the communication between data centers. So a mesh gateway is really providing that functionality. So given one single a service registry, services in one data center are going to be pointing to services in the other data centers through the mesh gateway acting as an ingress. But we can also use the mesh gateway as an egress, so we can control how the traffic is leaving the data center. So let me walk you through the Consul UI. So this is the Consul UI. Nick Jackson is doing an in-depth talk about Consul Connect later today. So if you are interested, have a look at the schedule, because this is going to be a very quick overview. We don't have time here to go in depth in the product. So we have here the service catalog. We have the nodes. In this case, we have a VMware node, which has been federated. So this is a VMware NSX service mesh, and this is the local node. And we have storage, we have ACLs, and we have intentions, so I can create intentions here. This is an inventory, really. So if I go into the different services, this Consul service is the Consul Connect service. So we can help see here all of the attributes of the different services. And we can continue doing things. So we can also use the API, but the API is providing more or less the same information than the one we have here in the UI. Talking about another implementation of service mesh, this is VMware NSX service mesh, and the differential value of VMware NSX service mesh is that we are providing a single pane of glass to scale service meshes using different clusters of different technologies. So for example, we can do all of the service mesh services like policy, telemetry, observability, etc., across a variety of infrastructure, so the user doesn't need to know really where the services are running, and the infrastructure becomes a pool of abstract infrastructure where the workloads can be moved across them. So we can have microservices migrating from one cluster to another, and from the operations perspective and developer perspective, it's going to be the same thing. Nothing is going to change, which is, if you think about VMware, that is very consistent to the way of how VMware has been delivering value, that is abstracting hardware or abstracting the infrastructure and providing infrastructure neutral constructs. So this is not different. And another big difference of NSX service mesh and differential value is that although in the current version of the product we only deal with services, there is a strong part of the vision that is coming next year is to extend the service mesh services to users and data as well. So for example, if today we can represent policies using services, next year we're going to be able to represent policies using different constructs, additional constructs, which are users and data sources. So if we zoom into that image, we have a high-level architecture, which more or less represents what I have been saying before. That is, we have service mesh services, discovery, visibility, control, and security across services, users, and data. And then we have a pool of infrastructure beneath the control plane. The control plane of NSX service mesh is a new control plane, and the underneath infrastructure, this is the way we are dealing with this infrastructure and the way we are providing the mesh services, is through Istio. So NSX service mesh is based on Istio, and it is providing all of the Istio functionality out of the box, in addition to the product-specific feature. If We think about scalability, and we think about a larger scale of service mesh. As I was introducing the talk, I was saying that we need to think about what happens when we want to do a model like this, but we are going to, instead of having 3 different clusters which are owned by the same company, what if we also need to interact with a piece of infrastructure which is not owned by the company, or it is owned by the company, but it is a different administrative domain. So we have no idea of what is going on there, and we will never be in agreement of how we are going to consume the infrastructure or a service mesh. So in those cases, then we need to think about different ways of integrating, and that is going to happen in many situations of virtual machines. It's going to happen in serverless infrastructure. It's going to happen if we want to extend the service mesh to SaaS applications. If we want our services that we are developing to interact with services created by a third party we don't have access to. So how do we do this? And the answer is interoperation. Right? Interoperation is a multi-mesh, multi-vendor, multi-product way of extending a service mesh. So we are making no assumptions when 2 meshes are interoperating about how the service meshes are implemented. And the only assumption we make is that they implement an interoperation API. That interoperation API is the work we have been doing with HashiCorp and a few other companies. And it is the basis of starting to think about in interoperating service meshes. So those service meshes which are interoperating need to begin with something. They need to provide a minimum set of services. So those services need to be available in all of the meshes that are interoperating. One is identity, another one is service discovery, and the third one is security. So interoperation comes, let's say, at the beginning with a single service registry across different service meshes and MTLS communication across services in different meshes. Before I go ahead, let me show you a little bit NSX service mesh. So this is the user interface of NSX service mesh. So what we have here is 2 different clusters. I have deployed an app in one of the traffics, and I am generating traffic to that app so we can see the service graph of the application. And then this also has an inventory, which includes the relationships between the services, right? So we can see here the different services, the instances. We can zoom into the services to see more things. So we can be navigating the service graph. We also have telemetry information as time series data. So we can know how the service has been behaving over time, different information like RPS, different kinds of latency, etc. And we can see how the service has been behaving in different moments in time. So we can aggregate data up to 24 hours, I think, yes. And then we have a representational a view of the inventory as well, which is, again, a way to navigate how the services are behaving, and the whole mesh is behaving. We have more features on top of this, but this is possibly not the right place to discuss all these things. So as I was saying before, the first thing we need to do to make 2 service meshes interoperate is they federate services between them. That is, given 2 service meshes, we need to make sure that these 2 service meshes can share control information. And to do that, we create an encrypted control channel between them. We authenticate service meshes between themselves. And we also have a mechanism to synchronize the services between service meshes. So as one service mesh is creating the services, the other service mesh is consuming them. How each service mesh implementation gives the user the ability to select which services are going to be federated with which other meshes, it is implementation dependent. So Consul has its own mechanism, NSXSM has its own mechanism, Istio has its own mechanisms. So that is a user experience perspective, and it's not part of the spec that we have created, as there are many other things we have left to the implementers, let's say, of the service meshes and the spec. And there should be also a way to create an encrypted channel between services across different meshes. So we need to think about interoperation not only between two different meshes, but across a variety of meshes. So we can have any number of potentially different meshes, synchronizing catalogs between them and creating a service-to-service communication between them. So to do this, we have used, as the use case is normally same company, there's normally a somewhere root CA, which has signed the certificates of the branches of the different departments or administrative units. So we're using the certificates which have been signed by the same root CA. So the way this works, it is, again, zooming in. On the left, we have NSX service mesh. On the right, we have Consul Connect. We have a federation agent, which is deployed in each of the meshes. The federation agent is a implementation neutral. So the federation agent is one of the parts we are going to be releasing in the open source. And it is basically running the mesh-to-mesh control protocol. Then it also runs the catalog synchronization between the meshes, but then once a service in one mesh wants to connect to a service in another mesh, the service can discover the other service in the mesh because there is an entry in the local catalog pointing to the service in the other mesh. However, how each mesh routes traffic securely, mesh on the left for exiting traffic and mesh on the right for traffic that is entering the mesh, it is also a implementation specific. So Consul has its own implementation because it is their mesh. NSXSM has its own implementation, and Istio will have its own implementation as well. So this is what is going to be happening. So if we want to connect the service foo on the left with the service bar on the right, we're going to have a federation agent which has synchronized, let's say, the service entry of the right-hand side bar on the left-hand side. So we have Consul bar on the left. But this is really mirroring the real service. So the IP address of this service is going to be the ingress of the other mesh. So this is the envoy is going to route the traffic through the egress on the left, and that traffic is going to be entering the Consul mesh on the right through the ingress. Questions at the end? Thank you. And then the envoy on the right is going to be terminating the channel. So I'm going to show you how this works in that direction and then in the opposite direction. We have 7 minutes on the clock, which is fine. I'm going to show you, this is running on Kubernetes. So basically what NSX Service Mesh does is that we install an Istio in the Kubernetes cluster, but we also installed a NSX Service Mesh, which is codenamed AllSpark services in the cluster. So we have access to the cluster using our own agents. And that's the reason why we cannot do this using, so we cannot extend the service mesh if we don't have access to the clusters, because we cannot install our agents in the cluster, and we don't know if we cannot touch those clusters at all. These are the services in the default namespaces. So these are the services which are being federated with Consul. So these are the services that NSX Service Mesh is exporting to Consul. So if we see Consul here, we see in the service catalog, this is NSXSM, that Consul has renamed those services, so we can search them in the catalog easily. And these are the services which NSXSM is federating with Consul. We can have services in different namespaces. And then we would like to communicate with one of the services that Consul is federating, and we're going to do that through one of the services that we have in the cluster. So we have the ping service in the cluster, and we're going to be executing a curl from that service, which is going to be calling a service that Consul is federating with NSXSM. So we need to find, in our implementation, what we have done is that we have used the HTO service entry to point to those entries in the Consul service mesh, in the other mesh. So we're going to see which are the entries in that registry, where the service entries are. And then we see here in the hosts that we have one service, one line, and then this is the name of the service. What we do not know yet is the port of the service. So if I get the service entry, namespace can be, no, it is there. We don't need namespace. Yeah, let me open another terminal. Should be the same name, yeah. So if we look at this, we have the IP address of the ingress in Consul. We have the port of the ingress. We have the name, that is the port number of the services with the service we are pointing in. We can know which is, let me go back to Consul. Here in the ingress, we have the port, right, and we have the address of the ingress here. So this is pointing to this ingress. And then I'm going to call that service, creating MTLS between them. In Consul, we can have a look at the service as well that we have connected with. And although this information that we've got through the API is the same information we have in the UI, we can use this to interact with the service as well. So we have here the same information, we have the port here, and we can get the ingress as well. So let me go back to the slides. And then we're going to see this in the opposite direction, which is, again, creating the control channel between the meshes, federating, then the service. This is exactly the same flow, but in the opposite direction. Bar in Consul is going to try to connect with foo in NSX service mesh. There is a local entry, so the service seems to be local, but it is not local. And traffic is routed through a mesh gateway in Consul and goes through the ingress in NSX service mesh, which is routing traffic to the envoy of the service instance. So this is the information of the sidecar in Consul. So to do that interaction in Consul, for this service bar to talk to the other service, we need to use a proxy. The proxy is explicit, so we need to call the local address of the proxy, which is a loopback address, and we need to use a port that is used in the proxy. So if we go to the, this is possibly much better to see in the UI. If we go to Consul, and we see the proxy here, so we're going to talk with this service at HTTP being NSXSM, and we have created a proxy for that. That is this one, the sidecar. If I go to the sidecar and I go to the app streams, this sidecar is pointing to HTTP bin, and this is the local port of the sidecar. So this is how I should call the service from Consul. Okay, and this is how I am doing it. So we have now created a communication in the opposite direction. And this is more or less how it works. There is still some work to do, obviously, so the solution is not perfect. But we are very proud that it is a good start. Thank you. So if you have questions, then we can talk down or back.